Hey there guys, welcome to my walkthrough of the OCR MEI new AS Level Maths Sample Assessment Material Paper 1, which is Pure Maths and Mechanics. Everything we need for this paper is in one document, which will be linked down below. So in this, you get the paper, the mark scheme, and the formula sheet. All of my other AS content, including past papers and chapter topic playlists, are linked down below in the description. Okay, let's go. Okay, question 1 wants us to simplify 2x squared y all cubed times 4x cubed y to the power of 5 all divided by 2x y to the power of 10. Okay. So, we've got okay, so first of all we need to expand that bracket. So, when you have powers separated by brackets, they multiply together. So, the 2 essentially has a power of 1. So we're going to get 2 cubed, which is 8. Then we're going to get x to the power of 2 times 3. So x to the power of 6. And then we're going to get y cubed. So then that's multiplying 4x cubed y to the 5 all over 2xy to the 10 . Okay, now we can combine the terms on top. So, what we do is we deal with each type of term one by one. So, if we do 8 times 4, we get 32. X to the 6 times x cubed is x to the 9. And y cubed times y to the 5 is y to the power 8. And that's all being divided by 2xy to the 10. Okay, so one more time, we work through again each type of term one at a time. So 32 divided by 2 is 16. X to the power 9 divided by x is x to the power of 8. And y to the power of 8 divided by y to the power 10 is y to the minus 2. So then, finally, we can write that as 16 x to the 8 over y squared. Cool. Question to just find the coefficient of the x to the power 4 term of the binomial expansion of x minus 3 to the power 5. Okay, so you are given the formula for binomial expansion. So it's a and b to the power of n is a to the power of n and n choose 1 times a to the n minus 1 times b to the 1. Now that is actually as far as we need to go, because if we found the first term, that's just going to be x to the power of 5, and then the second term, that's n choose 1, n for us is 5. Now the power of x goes down by 1, so we get x to the 4, and then the power of minus 3 goes up by 1. So the coefficient of x to the 4 is 5 choose 1 times minus 3. Now 5 choose 1 is 5, so we get minus 15. Cool. Okay, number 3, first bit of mechanics. So figure 3 shows a particle of weight 8 newtons on a rough horizontal table. Now when they put the word rough in when describing a surface, that means friction is a thing. If we're told the surface is smooth, we ignore friction. So here there is friction. The particle is being pulled by a horizontal force of 10 newtons. It remains at rest in equilibrium. Okay, so from the diagram we can see it's being pulled to the left. Part A says what information given in the question tells you that the forces shown in figure 3 cannot be the only forces acting on the particle. Okay, so it's the fact, I'm not even going to write it down, it's the fact that the particle is in equilibrium. That means the resultant horizontal force has to equal 0, and the resultant vertical force also has to equal 0. If the 10 newtons to the left was the only horizontal force, then the particle would be flying off to the left, and if the 8 newtons was the only force acting vertically, it would fall through the table. So part A is that the particle is in equilibrium. Then part B says the only other forces acting on the particle are due to the particle being on the table. State the type of the forces and their magnitude. Okay, so for the particle to be in equilibrium, horizontal forces need to be equal and vertical forces need to be equal. So, if there is a 10 Newton force pulling the particle left, there has to be a 10 Newton resistant force acting to the right. Now that would be friction. And then in terms of the vertical forces, well, 8 newtons is the force of weight, so the table, for the particle not to be falling through the table has to be pushing up with the same force. So that is called a normal reaction force, and that would have to have magnitude 8 newtons. Cool. Question 4a wants us to express x squared add 4x add 7 in the form x add b squared add c. So this is completed square form. Okay. So okay, so completing square gets taught really badly, I think. Lots of people struggle with this. You literally half a number, square it, and then subtract it. So, we need one pair of brackets with a square on the outside, 1x. Now we half the x coefficient in the middle. So half of 4 is 2. So we put that inside the bracket. Now for now, the 7 can stay on the outside, and then we subtract the number inside of the brackets with the x squared. So 2 squared is 4, so we subtract 4. So finally we get x add 2 squared add 3. Cool. So that's part A. Part B then wants us to explain why the minimum point on the curve y is equal to x add b squared add c occurs when x is equal to minus b. Okay. So, when y is equal to x add b squared add c, well, because we have a square on the outside of this bracket, this is always positive. except when x is equal to minus b. In which case it's equal to 0. So, for x add p squared add c to be a minimum, x add b all squared must be 0 because any other value it takes is bigger than 0. And so the minimum occurs when x is minus b. Go. Number 5, more mechanics. So particle p moves on a straight line that contains the point O. At time t seconds, the displacement of p from O is s meters, where s is t cubed minus 3t squared add 3. Part A. Determine the times when the particle has 0 velocity. Okay, so velocity is the rate of change of distance over or displacement over time. So what we need to do first of all is find an expression for the velocity. So s is t cubed minus 3t squared add 3. Now velocity is the derivative of displacement with respect to t. So that's going to give us 3t squared minus 6t. Now we want the particle to have 0 velocity, so that means v is equal to 0. Now that means then 3t squared minus 6t is equal to 0. Now, it's very tempting to divide away the common factor of t. Don't do that though, because you lose a solution. Instead, factorize. So, we get t, lots of 3t minus 6. Now, what we could have done is divided through by 3. So we would have t times t minus 2 now that tells us v is equal to 0 when t is equal to 0 and 2. Cool. So there's part A. Part B wants us to find the distances of B from O at the times when it has 0 velocity. Okay, so all that we need to do now is substitute our values for t into the displacement. So when t is 0, s is 0 cubed is 0, 3 times 0 squared is 0, so we just get 3. And then when t is 2, s is 2 cubed is 8. Minus 3 lots of 2 squared is minus 3 times 4 is minus 12. And then we have the plus 3 at the end. So that's 11 minus 12, that's minus 1. But we need to be very careful here. The question said to find the distance from O. So the displacement being minus 1 means the particle is 1 behind O. So the distance when t is 2 is 1 meter. And up here as well, we should really have 3 meters. Cool. Okay, question 6. Fun with vectors. So 2 points A and B have position vectors. A is I minus 3j, so that just means 1 to the right, 3 down, and B is 4i add 3j. So 4 to the right, 3 up. The point C lies on the line y is equal to 1. The lengths of the line segments AC and BC are equal. Determine the position vector of C. Okay, so I'm going to think of these vectors in Cartesian form. So all that means is as coordinates on an XY grid. So let's draw some axes we go. Now, point A, or A has position vector I minus 3j. So we can think of a point A having coordinates 1 minus 3. And then we can think of a point B as having coordinates 4, 3. Okay, now we know that the point C lies on the line y is equal to 1. So the line y equals 1 is just a horizontal line going across like that. So the point C lies somewhere on this line. Now we know the y coordinate of C is 1. Now what we're going to do is we're going to call the x coordinate x for now. So what we can do is find the length of AC. So we can now think of this as Pythagoras. So we know it's going to be the square root of x minus 1 squared add 1 minus 3 squared, so 4 squared. Now of course, what we're really doing, we are finding the magnitude of the vector A to C. So that's the square root of x squared minus 2x and we would get add 1 and then we got add 16, so we got add 17. Now if we do the same for C to B, then the length C to B is the square root of 4 minus x squared add the height, so that's 2 squared, so that's add 4. Now if we expand, we get x squared, or the square root of x squared minus 8x. Add 16 add 4, so let's add 20. Now we know that the lines AC and BC have the same length, so we can now say that the square root of x squared minus 2x add 17 is equal to the square root of x squared minus 8x add 20. Now we can square both sides. We can subtract x squared from both sides. Okay, then we want to solve for x. So if we add 8x to both sides, 6x add 17 is equal to 20. Now we can then subtract 17, so 6x is 3, and then divide by 6x is 1/2. So the coordinates of C are 1/2, 1. The position vector is then 1/2 I add j. 1/2 to the right, 1 up. Cool. Okay, number 7. This could be a fun one to explain, so I will do my best. So a car is usually driven along the whole of a 5-kilometre stretch of road at a constant speed of 25 metres per second. On one occasion, during a period of 50 seconds, the speed of the car is shown by the speed time graph in figure 7. So the rest of the 5 kilometres is travelled at 25 metres per second. So the part that we are interested in is this bit in the middle. So it looks like it was drawn by monkeys. So what we are given is the times between the change in speed of the car. So we got a decreasing speed for 20 seconds, a constant speed then for 20 seconds, and then we speed back up for 10 seconds to get back up to 25 metres per second. So our mission is to work out how much more time than usual did the journey take on this occasion. So you're working clearly. Okay, so the first thing that we should do is work out how long the journey takes usually. So speed is distance over time. So time is distance over speed. Now, our total distance is 5 kilometers, so 5,000 meters. Our speed is 25 meters per second, so we want to do 5,000 divided by 25, and that gives us our usual time is 200 seconds. Okay, now what we need to do is, first of all, remember that the area under the graph on a speed or velocity time graph is the distance. So what we need to do is, for this 50-second part of the journey, we need to work out this area under the graph. Now, to do that, we are going to make a sketch. So, on the graph, we got this rectangle. Now we know the time along the bottom is 50 seconds. And the height of the rectangle is 25 meters per second. Now, we could work out the total distance in that. So, distance here would be 25 times 50, which is 1,250 meters. But that is not the distance travelled in this time, because our speed drops. So, what we want is the area down here. What we don't want is the area of this trapezium. So we need to work out the area of the trapezium and then subtract that from 1,250. And what that's going to tell us is how far we travel in this 50 seconds. So, the area of a trapezium if we call the bottom B, the top A, and the height H, and then the area is H times A add B all over 2. So, we need to find some dimensions of our trapezium. So, the height is the difference between 10 and 25, which is 15. We know the top is 50 and the base is 20. So, the area then, so let's call this the red area. So this is going to be 15 times 50 add 20 all over 2. Now that is going to give us 525. So, don't know why I'm writing in boring black. The distance travelled in this 50 seconds is the 1,250 meters minus the 525 meters, and that is 725 meters. Okay, so that's how far we travel in this 50 seconds. To finish this off, we now need to work out how much further there is to travel. So that's the whole 5,000 minus 725, which is 4,275. So we then need to work out the time it takes to travel that distance. Well, that's 4275 divided by 25, and that gives us 171. So the total time is 50 add 171. And that is 221 seconds. Which is 21 seconds more than usual. Remember, we worked out usually it takes 200 seconds for the journey. Cool. Okay, question 8. Fun with circles. Circle as equation x minus 2 squared add y add 3 squared is equal to 25. Part A wants us to write down the radius of the circle and the coordinates of the centre of the circle. Okay, so a circle centered at A, B with radius R has equation x minus a squared add y minus b squared is equal to r squared. So that means then for us our radius is the square root of 25, which is 5, and our x coordinate of the centre, we have x minus 2 squared, so that's positive 2, and we have y add 3 squared, so that's minus 3. So there is part A done. Part B wants us to find an exact form the coordinates of the points of intersection of the circle with the y-axis. So on the y-axis, what do we know? Well, on the y-axis, x is equal to 0. Now that means then we substitute x is equal to 0 into the equation of the circle. So when x is equal to 0, we get minus 2 squared add y add 3 squared is equal to 25. Now, minus 2 squared is 4. So if we take 4 away, we get left with y add 3 squared is equal to 21. Now if we square root, now be very careful here, when you square root you get positive and negative answers. So we get y add 3 is plus or minus root 21 take away the 3, y is minus 3 plus or minus root 21. So the coordinates then are 0, minus 3, add root 21, and 0, minus 3, minus root 21. Go. But C wants us to show that the point 1, 2 lies outside of the circle. So let's think about this. How are we going to do that? Well, we know that a point on the circle has to be 5 away from the centre. So the length of the line from the centre to a point has to be the radius for that point to be on the circle. If the distance is less than 5, the point is inside the circle, and if the distance is greater than 5, then the point is outside of the circle. So, our centre is 2 minus 3. And this point has coordinates 1, 2. So that's to the left and up. Let's call it, I don't know, A. Why not? Okay, now the length that was never going to go very well. Okay, now the length AC and it's Pythagoras. So our height is 5, so it's the square root of 5 squared, add the length, which is just 1, so the square root then of 5 squared add 1 squared is root 26. Now that is greater than root 25. Therefore, A is more than 5 from the centre so is outside of the circle. Cool. Okay then, part D, final part, the point P minus 1, 1 lies on the circle. We want to find the equation of the tangent to the circle at P. Okay, let's make a sketch. So, there's our circle. Now we know the centre is 2 minus 3. And we know that P is minus 1, 1, so that's to the left and up. So it's going to be about there, maybe. So we want the equation of the tangent that hits the circle at this point. So not quite there. There we go, not perfect, but you get the idea. Okay, so how do we do this? We use the fact that the radius meets a tangent at 90 degrees, so they are perpendicular. Now, why do we do that? Well, that's because we can find the gradient of the radius, because we know 2 points that lie on the radius. Using that and perpendicularness, which is definitely a word, we can get the gradient of the tangent and then the equation. So, gradient of the radius, difference in y over difference in x. So, I'm going to go 1 minus 3, so that's 4, over minus 1 minus 2, so that's minus 3. So that's minus 4/3. Now, because the radius and the tangent are perpendicular, their gradients multiply together to minus 1, or, more simply, the gradient of a tangent is the negative reciprocal of the gradient of the radius. So the gradient of the tangent is positive 3/4. Okay, so now we use the general equation of a straight line. Y is mx add c. So we can say up to now, the tangent is of the form y is 3/4 x add c. Now to find c, we substitute in the set of coordinates that we know lie on the tangent. So that's minus 1, 1, so when x is minus 1 and y is 1, we get 1 is equal to 3/4 times minus 1, so that's minus 3/4 add c. So therefore c is 7/4 and our tangent is y is 3/4 x. Add 7/4. Go. Number 9, modelling with logarithms. So, a biologist is investigating the growth of bacteria in a piece of bread. He believes that the number n of bacteria after t hours may be modelled by the relationship n is equal to a times 2 to the kt, where a and k are constants. But a wants us to show that according to the model, the graph of log base 10n against t is a straight line, and we need to give, in terms of a and k, the gradient of the line and the intercept on the vertical axis. Okay, so n then is a times 2 to the kt. Now, given that we want log 10n against t, we're going to need to take the log base 10 of both sides. So we get log. Now, when you write log without a base, it is log base 10. So to cut down notation, I'm not going to write in the bases. So we can say log n is equal to log of a times 2 to the kt. Now, using the laws of logs, on the right we can split that into log 2, no we can't, log a add log of 2 to the kt. So that's by using the addition law of logarithms. When you add logs together, you multiply the things inside of the logs. So we've just done that backwards. Okay, now we're going to write that in a different order on the right. So I'm going to write it as log of 2 to the kt add log a now, also by the rules of logs, by the power rule, we can write log of 2 to the kt as kt log 2. Okay, now I'm going to write that first term slightly differently. So I'm going to write this finally as log of n is equal to t times k log 2 add log a. if we compare this to y equals mx add c, which is the general equation of a straight line, then our y is log tan of n, our m is k log 2, so the gradient is k log 2. The x here is our t is the variable, and c, the y-intercept, or here the log tan n intercept, is log a. So the vertical axis intercept is log a. Cool. Next up, the biologist measures the number of bacteria at regular intervals over 22 hours and plots a graph of log tan of n against t. He finds that the graph is approximately a straight line with gradient of 0.2, and the line crosses the vertical axis at 2. Part B wants us to find the values of A and K. Okay, so he has found the gradient to be 2. We have found the gradient to be k log 2. So we know then that k log 2 is equal to 0.2. So k is 0.2 divided by log 2. Now that, if we go to 3 decimal places, is 0.664. Okay, and then he has found the intercept to be 2. Our intercept is log A. So, which means then that log, now we put a 10 back in here, so log 10 of A is equal to 2. Now, that means that 10 to the power of 2 is equal to A. So, A is 10 squared, which is 100. So we don't need to here, but what we can do is write out his model. So we now know that n is 100 times 2 to the 0.664 t. Cool. Okay, then part C wants us to use the model to predict the number of bacteria after 24 hours. So, we're going to need the model that we just wrote down. So, when T is equal to 24, N is equal to 100 times 2 to the 0.664 times 24. Now, you should get 6 million, so things have certainly escalated. 6,269,000 227. So, in the mark scheme, they've rounded up to 6,300,000, but that would be the exact answer that we would predict. Okay, then part D, classic question you usually always get one like this. We want to give a reason why the model may not be appropriate for large values of t. So, the answer is that there is no cap or limit to the model. So, by the model, as time gets bigger and bigger and bigger, the number of bacteria tends to infinity, which can't happen, it's only on a piece of bread. So that would be why the model would be inappropriate in the long term. Cool. Okay, 10a wants us to sketch the graph of y equals 1 over x at a, where a is a positive constant. We need to state the equations of both asymptotes and give the coordinates of any points where the graph crosses the axes. Okay, 4 marks. So, the first thing I'm going to do is remind you what y equals 1 over x looks like. Now, remember, x cannot equal 0 because we can't divide by 0, it's illegal. And 1 over x itself can also never equal 0. So, as x gets bigger and bigger and bigger, positively, y gets smaller and smaller and smaller. As x gets smaller, y gets bigger and bigger and bigger. So it's inverse proportion. So, in the top right part of the graph, it looks something like that, although managed to make it look like it hits the x-axis, which it doesn't. Okay, that's not the end of the story. It also does the same thing down in the negative part of x and y. So that's how y equals 1 over x looks. It's one that we should be familiar with, but who knows. Graphs is always something I struggled with myself. So let's now think about y equals 1 over x add a. Now, first of all, we need to think about what this plus a at the end does. So that is a translation up by a places. So in vector form, that's 0, a. So we can start to sketch the graph. So the top right isn't going to look too different. It's going to look something like that. And the bottom left is going to look a bit different. It is now going to cut the x-axis. That doesn't look very good. Let's try that again. So, that's better. Okay, so that's how our sketch is gonna look. Now the vertical asymptote stays the same, but for the horizontal asymptote, we need to think about what the asymptote was for this guy. So, because 1 over x can never equal 0, that means our vertical asymptote is y is equal to 0. Now, on y equals 1 over x add a, the horizontal asymptote has gone up by a places. So, that is going to look something like that, and that is going to be the line y equals a. And our vertical asymptote is just the y-axis, which is x equals 0. So, let's write those down. So, horizontal is y is equal to a, and vertical is x equals 0. Okay, now the final thing we need to do is find the x coordinate of this point. Now, at that point, let's call it P. At P, well, we're on the x-axis, so we know that y is equal to 0. So that means 1 over x add a is equal to 0. So, if we subtract a, we get 1 over x equals minus a multiplied by x. 1 is minus a x. Divide through by minus a. Minus 1 over a is equal to x. So, point P has coordinates minus 1 over a 0. Cool. So, let's put that on our sketch. Cool. There is our sketch. Part B for 5 marks. Find the equation of the normal to the curve y equals 1 over x add 2 at the point where x is equal to 2. 5 marks. Okay, so game plan. A normal is a straight line perpendicular to a curve at a certain point. If it's perpendicular, then the gradient of the normal times the gradient of the curve at this point is equal to minus 1. So, if we find the gradient of the curve at this point, we can then find the gradient of the normal, and we can then use y equals mx add c to find the value of c. To do that, we are also going to need the y coordinate at this point. So that's the very first thing I'm going to do, is find the value of y when x is equal to 2. So, when x is equal to 2, y is equal to 1/2 add 2 which is 5/2. So this point is 2 5/2. Okay, so we now know both coordinates of this point. So let's now find the gradient of the curve. Okay, so we know that y is 1 over x add 2, so 1 over x is x to the minus 1. So we have x to the minus 1 add 2. Now to find the gradient of the curve, we need to differentiate. So dy by dx is going to be minus x to the minus 2. So that's minus 1 over x squared. Now, that then is the gradient of the curve. So, the gradient of the curve at 2 5/2 well, we just substitute in the x value. So we get minus 1 over 2 squared minus 1/4. So now we know the gradient of the curve at the point, we can now work out the gradient of the normal. So normals are perpendicular to the curve, so the gradients multiply together to minus 1. More simply, the gradient of the normal is the negative reciprocal of the gradient of the curve. So the gradient of the normal is positive 4 over 1. So that's just 4. So, now we can start putting the normal together using y is mx add c. So, we can say that the normal is y is equal to 4x add c. Now, to find c, remember what we did right at the start. We found the y coordinate of the point, so we now know there is a point on this normal when x is equal to 2 and y is equal to 5 halves. So we substitute those coordinates in, so we get 5 halves is equal to 4 times 2, which is 8. Add c. Now 8 is 16 halves. 5 halves minus 16 halves tells us then that c is minus 11 halves. And then finally, the normal is y is 4x minus 11 halves. Boom. Now if you want all the workings together, there you go. Go. Okay, then part C wants us to find the coordinates of the point where this normal meets the curve again. So, let's go back to our sketch briefly, just to try and explain what's going on. So, let's say the point that we just found was 5 over 2, so let's say it was this point here. Now, we've found the equation of the normal to the curve at that point. Now, what's going to happen is the normal goes through the curve there and then meets it again somewhere over on the left. So it's going to be around here somewhere. Now remember, that's just a sketch, so just because it looks like it's on the x-axis there, it's probably not going to be. Okay, but that's what's going on. Okay, so we know the equation of our normal is this chap, and we know the equation of the curve is 1 over x add 2. Now, at intersection points, the equations are simultaneous or equal to each other. So, we can say that 4x minus 11 over 2 is equal to 1 over x add 2. So we now need to solve these equations simultaneously to find the value of x. So if we multiply through by x first of all, we are going to get 4x squared minus 11x over 2 is equal to 1. Add 2x. Okay, if we then multiply through by the 2, we then get 8x squared minus 11x is equal to 2. Add 4x. Now, this is a quadratic, so we need to get everything on the same side with a 0 on the other. So now we're going to subtract 4x and subtract 2. So we're going to get 8x squared minus 15x minus 2 is equal to 0. Now that doesn't look overly nice, but remember, we know that 2 is a root, because we know that the normal hits the curve at x is equal to 2. So that tells us x minus 2 is a factor of the quadratic. So we can factorise this. We know we're going to have a factor of x minus 2. Now that means the other bracket has to have an 8x. And then to get a minus 2 at the end, we need a plus 1. So let's check that. 8x times x is 8x squared. 8x times minus 2 is minus 16x. 1 times x is 1x. That gives us our minus 15x. And then we got a minus 2 at the end. So, from that, x is positive 2, which we knew. Or, well, 8x add 1 is equal to 0, so x is minus 1/8. So that's the one that we are interested in. So we now need to find the y coordinate. So probably the easiest way to do that is remember that y is 1 over x add 2. So when x is minus 1/8, y is 1 over minus 1/8, so that's minus 8. Add 2, which is minus 6. So the other point is minus 1/8 minus 6. Boom. Now again, if you want all the workings in one place, if anyone wonders why everything is so zoomed in, I make these on a tablet, not a big whiteboard. So, if anyone wants to buy me a big whiteboard, that would be amazing. Jokes. Okay, number 11, it's 6 marks, and in this question, you must show detailed reasoning. So, we want to determine for what values of k the graphs y equals 2x squared minus k, minus kx, and y is x squared minus k intersect. Okay, so first of all, intersection points happen when the graphs are equal. So intersections occur when two x squared minus kx is equal to x squared minus k. Now, this is a quadratic. To solve it then, we need to get everything on the same side. So, if we subtract x squared and add k, we get 2, no we don't, we get 1x squared minus kx, add k is equal to 0. Okay, now then, this is a quadratic, so when we're thinking about there being solutions, we now need to think about the discriminant. So, for one real root, so for one point of intersection, we know that b squared minus 4ac is equal to 0. And for 2, b squared minus 4ac must be greater than 0. So, that means then for the graphs to intersect b squared minus 4ac has to be greater than or equal to 0. Now then, A is 1, B is minus k, and C is positive k. So, minus k squared minus 4 times 1 times k, so minus 4k is greater than or equal to 0. Now, minus k squared is k squared, so we have k squared minus 4k has to be greater than or equal to 0. Now, if we think about this now as an equation equal to 0, it factorizes to k times k minus 4 is equal to 0. So that tells us k is equal to 0 or 4. Now, if we sketch the graph of k squared minus 4k, we then know that it looks like this. So it cuts the x-axis at 0 and 4. Now, remember that we wanted k squared minus 4k to be greater than or equal to 0. So we are interested in the values of k that produce the parts of the graph on or above the x-axis. So that part and that part. So that then gives us k is less than or equal to 0 and k is greater than or equal to 4. Boom. Okay, number 12, here we go. So a box hangs from a balloon by means of a light inelastic string. Now the string is always vertical and the mass of the box is 15 kilograms. Catherine initially models the situation by assuming that there is no air resistance to the motion of the box. Use Catherine's model to calculate the tension in the string if part A, the box is held at rest by the tension in the string. Okay, so I've made a diagram. So there's our balloon and there's our crate. Hello to any Crash Bandicoot fans out there. So what's going on? Well, the forces that we have are the tension in the string is pulling the box up, and the weight of the box is trying to pull it down. Now, weight is mass times gravity, so weight is going to be 15 times, we haven't been told what to use for gravity, so I'm going to use 9.8. So the weight is 15 times 9.8. And that gives us oh man, do you ever feel like your phone hates you? 15 times 9.8 is 147 newtons. So, for part A, for the box to be at rest, the resultant force needs to be 0. So that means tension has to be the same as weight. So tension is 147 newtons. Part B wants us to calculate the tension if the box is instantaneously at rest and accelerating upwards at 2 meters per second squared. Okay, so this one's 2 marks. Slightly trickier. We need to use, or we need to devise an equation of motion for the box. So, this is where our best mate Newton comes in. So we know that force is mass times acceleration. So here, that is 15 times 2. Which is 30 newtons. Now we can say that that same force is, well, we know the box is moving upwards, so tension is winning, so the force is also tension minus the weight, so minus 147 newtons. So that tells us then that tension minus 147 is equal to 30. Therefore, tension is 177 newtons. Cool. And part C wants us to calculate the tension if the box is moving downwards at 3 meters per second and accelerating upwards at 2 meters per second squared. So, with these two questions, they've sort of tried to, part B and part C, they've sort of tried to trick us a bit by putting velocities in. Force doesn't care about velocity. Force only cares about acceleration. So, given that we've got the same acceleration as part B, the force is the same. So, same acceleration as B. So T is 177 newtons again. Okay, then for the final part, Catherine now carries out an experiment to find the magnitude of the air resistance on the box when it is moving. At the time when the box is accelerating downwards at 1.5 meters per second squared, she finds that the tension in the string is 140 newtons. But D wants us to calculate the magnitude of the air resistance at that time and give, with a reason, the direction of motion of the box. Okay, so what do we know then? Well, we know the weight acting down is still 147 newtons. Now we know tension is pulling us upward, so that's 140 newtons. Now, because we don't know which way the box is moving, we don't know which way air resistance is pushing. So, if the box is going up, air resistance is acting down. If the box is going down, air resistance works up. So, I'm going to think of air resistance as an upward force to start off with, and I'm going to call it A. Now, if we calculate A to be negative, that means it's actually working downwards. If positive, it's working upwards. Okay, so if we calculate the resultant force, so the resultant so if we add the two upward forces, we get A at 140 and then we subtract the downward force, so minus 147. Now this gives us A minus 7. Now we also know that the box is accelerating downwards, so this same force is equal to the mass times minus 1.5. It's minus because it's accelerating downwards. So we also know then that A minus 7 is equal to 15 times minus 1.5. Now this gives us A minus 7 is equal to minus 22.5. So A is minus 15.5. newtons. Now the question wanted the magnitude, so the magnitude of A is 15.5 newtons. Now A is working downwards, so that means the box is moving upwards. Cool. Okay guys, that's the paper done. Really hope you found it useful. Don't forget, give us a thumbs up, get subscribed, and take it easy. Take care.